is dependent and independent events. So we'll look at that, and then we'll go through some examples on that as well. I'm glad to see you guys are already standing by. Okay, yesterday's lesson, what did we learn about? We had a quick review of probability. Like I said, we always go through everything that we've done just to make sure that we are up to date. And then we spent some time with two-way tables. Now, tomorrow will just be about practice. So tomorrow we're going to take everything that we've done this week. I'm going to have some questions ready for you guys, and we're just going to work through some questions. Practice it in. And then probability. Let's quickly, I'm going to ask you guys again, and you should know this by now because I've asked you this question a lot. Probability, what is it? What is probability? Who can tell me? Who can tell me what is probability? As soon as I get that answer, I'm going to answer Vicky's question that I just saw pop up on the screen. Who can quickly tell me what is probability? Megan, first one up, likelihood that something will happen or the chance of it occurring. Wow, very nice. I couldn't have even said that better. Cassie, beautiful. Okay, very nice. Yes. The probability is the measure of how likely it is that something will happen. Okay. Or the study of the chance of things happening in the future. For example, if we say, I'm going to flip a coin, how likely is it that it will land on a head or a tail? Flipping, oh wow, look at that. Vicky is even jumping ahead. She says, like when flipping a coin or rolling a dice. There we go. 50% chance of either head landing on head or tail. And then the chance of things happening is, for example, like the weather. Whereas, you know what, if it rains today, and if it rains today, the likelihood that it will rain tomorrow will, because of information we have gathered before, we can then determine whether or not, you know, what the probability it is of it raining tomorrow. Because if we take all the data we have and we say, okay, you know what, every time it rains, the following day has a 30% chance of rain. So we can go back and look at that. But like I said, we'll do some examples of that later. The probability scale, on the one side, we've got things that are impossible. And then on the other side of the scale, we have things that possible. There we go. Thank you, Megan. We have things that are possible. Right in the middle, what are the chances of things happening? Okay, wow, Megan is giving me everything. Yes, the probability of an event that is impossible is 0 or 0%, like I'm showing there on the screen right now. We represent that by a 0. And then if something is possible, we represent that by, thank you, Vicky. Yes, we will represent that by 1 or 100. Okay, now that I see Vicky's name, I also said I'm going to talk about her questions. She asked about Kahoot. I would love to play Kahoot with you guys, but being a relatively new teacher online, I am still practicing with Kahoot. So I'm going to play Kahoot with you guys next week if you don't mind. I really want to make it fun, so I'm just practicing with it. I don't know it that well. So if you don't mind, give me a chance to practice this weekend and then we'll play next week. Okay. Thank you, Vicky. Thank you, Lionheart. I appreciate it. Okay, and then in the middle, we've got an even chance, 50-50%. Okay, 1 on 2. And then also, the closer we go to 0, to impossible, the less likely it becomes. And the closer we go to possible, the more likely it becomes. Okay, so give me just a quick run through. What are the 3 ways we can represent probability? On the screen, there's a half, so that is a fraction. What are the other 2 ways? There we go, fraction. And if we divide 1 by 2 or 3, a percentage or a decimal. There we go, you guys. Absolutely great. I love it. Very nice, very nice. Okay. Ooh, let me take that away quickly. Our probability formula. Remember, we have probability equals the number of successful outcomes over the total number of possible outcomes. Okay. Now, let's quickly look at this. Here, I've got a probability scale, and I have 5 events down at the bottom in the blue squares. Okay, the first one, coin landing on a head, rolling a 7, that the next car will be white, tomorrow will be Friday, raining in the desert. Okay, so let's go to the first one, and we look at coin landing on a head. So we have to arrange these items on the probability scale of impossible to possible. So coin landing on a head, I can already see you guys, Vicky, Lionheart, you guys, Megan, half. So let's see if I click. Yes, coin landing on a head is even chance because there are 2 sides, head and tail. Let's look at number 2. It says rolling a 7 with a die. What is the probability of that happening? Rolling a 7 on a die. Likely, unlikely, unlikely. I see Megan said impossible. Lionheart, impossible. Why is it impossible to roll a 7 on a die? How many sides are there to a die? Only 6. There we go. So it is absolutely impossible to roll a 7 on a die. Okay, so it is impossible. Now, the next one, it says the next car, if we drive down the road and it says the next car I'll see will be white. Okay, so sometimes we can look at an answer and say, I'm not sure exactly where it should be, but I can guess likely, likely. Why do you guys think it's likely that the next car I'll see is white? Because it is a known fact that most cars out there, because there are a lot of cars, and yes, most of them is white. So yes, it is. Oopsie, let's move that one back. But if we don't know whether it's possible, likely, unlikely, we go on to something that we do know. So let's just pretend that we're not sure about that one. So let's move on to the next one, see if the next one might be a little bit easier. Okay, there we go. Cassie says it's a common color. Most are white. But let's say we don't know, we're not sure. Tomorrow will be Friday. Vicky asked, where did I get white? That is just a question. I'm just asking you guys to put it on the scale. What are the chances of it happening? So it's just a random question. So yes, 100%. Megan, tomorrow will be Friday. We all know that today is Thursday, so tomorrow will be Friday. It is absolutely possible. Yes, 100% tomorrow is Friday. Okay, now we only have 2 left. We've got raining in the desert, and we've got the next car will be white. Okay, so yes, like you guys said in the beginning, it is likely that the next car will be white because it's a common color. Most cars that they make are white. And then raining in the desert. Raining in the desert, is it totally impossible for it to rain in the desert? Is it impossible, Sharon? Likely. Vicky says likely. No. You can't have a sample space for them, but that is assumption though. Okay? It is unlikely. Yes, it is possible for it to rain in the desert. Every now and then the desert does get rain, but it can rain there, but it doesn't happen often. Okay, so it is unlikely. Okay, there we go. Lionheart said because every year it at least rains 2 or 1 time. So it does happen. It's very rare. Thank you, Vicky. Yes, it doesn't happen a lot. So it is unlikely. Okay, so that is how the probability scale works. We can arrange items from impossible to possible. Now, I'm quickly going to ask you guys to give me an example of an event that is possible. Who can give me an event that is possible? I want 2 other events that are possible. Two events that are possible. Come guys, give me 2 other events that are possible. Anything that is absolutely 100% possible. Anything, yes. Okay, yes. Someone dying, the sun will set. There we go. Yes, the sun will set. Okay, COVID-19. Very funny, Vicky. Yes, guys, a nice example is the sun will set tonight. The sun will come up tomorrow morning. Okay, there might be clouds. We might not see it, but yes, the sun does still come up. Okay. 365 days a year. Okay. Give me something that is even chances, an even chance of happening. Something else that is an even chance of happening, like a coin landing on either head or tail. Any other examples of something an even chance of happening? An even chance. Come, guys. Remember, if you just say dice rolling, a die has 6 sides. So if you say even numbers and odd numbers, yes, then there's an even chance because you've got 3 odd numbers and you've got 3 even numbers. Okay, then we have an even chance. Okay, so 3 odd, 3 even. That's an 3 odd, 3 even. So that is an even chance. Or if we can say that, you know what, the baby that will be born will either be a boy or a girl. Okay, it won't be an alien. So it will either be a boy or a girl. So, and then give me something else that is absolutely impossible. What cannot happen? Something impossible. Impossible, 5 going into 1. 5 cannot go into 1, or 5 cannot be go into 2. Okay. Vicky, I'm not sure. Maybe the sun will blow up one day. We're not sure. Maybe. I'm not sure. Okay. But you guys get the idea. So if I give you an event you can put it somewhere on the scale of it happening. Okay? Let's say I am the best 10-pin bowler there is. What are the chances that I will get a strike? Remember, a strike is when I roll down all 10 pins. So I'm the world's best. I'm the world's best bowler. What are the probabilities of me getting a strike, getting all 10? Be careful, guys, because remember, if you go 10-pin bowling, now here, this is where we say we look at the study of the chance of something happening. Now, I'm the world's best 10-pin bowler. Now, if you guys ever watched 10-pin bowling, they roll a strike almost every single time. So it is very likely, if I am the world's best 10-pin bowler, I will be over here, quite possible, or very, 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 very close to that line, that I will get a strike. But let's say there's a 5-year-old boy. He has never played 10-pin bowling. Okay, where will he be? Will he get a strike? No, he will probably be down here somewhere. Maybe if he's very lucky, he'll get a strike. Okay, so that's the same event, but depending on certain variables, there can be a different outcome. Okay, so just keep those kind of questions in mind, that yes, a 5-year-old boy that has never played before, the possibility of him getting a strike is almost impossible or very, very unlikely. Whereas if I'm the world's best player, it will be almost 100% of the time I will get, let's say 95% of the time, I will get a strike. But this is where we have recorded the likelihood. So I've played for 20 years, and every time I roll, we record, yes, strike, yes, strike, yes, strike. So if we record something, those probability equations will change a little bit. But because that, then we record the chance of something happening because of information we have from a record that we have kept. Okay. Now, here is Vicky's question from yesterday. We'll be reading dependent and independent probability. Now, I'm going to ask, what is dependent probability? What is dependent probability? Who knows what dependent probability is? Come, guys, let's keep the chat within about the work, and we can get this. We can get through this. What is dependent probability? It can happen on its own. Okay. Let's see. Dependent probability. The outcome of an event is affected by the outcome of the previous event. Okay. So unfortunately, it's not something that can happen on its own. This one depends on something that has happened. So let's look at this example. We've got a bag, and in that bag we have 5 marbles. Okay, we've got three orange marbles, and we've got 2 blue marbles. Okay, so if you put your hand into the bag and you just take out one marble by chance or just randomly, who can tell me what would the probability be of drawing an orange marble? What's the probability of drawing an orange marble. There we go, 3 out of 5. We've got, remember our formula, it is all the favorable outcomes over all possible outcomes. So yes, if we look at that, I had it the wrong way around. 3 orange marbles, so 3 out of 5. Blue would be 2 out of 5. If I just said, what is the probability of getting a marble? It will be 5 out of 5. Okay, so yes. Now, with dependent probability, this is where dependent probability comes in. I'm going to pause here quickly because I see a question now. There is currently a 0.0019 chance of catching. So if there is a chance, it cannot be impossible, right, Louis? If you in your sentence, you said there is currently a 0.0019 chance of catching the coronavirus. That's not an impossible event. No, that's not. It's not an impossible event because you even state that there is a chance of it. It's very, very, very small, but yes, it is still a chance, but it will be very close to impossible. It is going to be very, very unlikely. Okay, I hope that answers your question. But let's go back to the dependent probability. We've got the bag, 5 marbles, 3 are orange, 2 are blue. If you stick your hand in it, there's a 2 in 5 possibility of getting a blue one and a 3 in 5 possibility of getting an orange one. But here is where dependent probability comes in. If I take out an orange marble, okay, what do I have left? I've got 2 blue, 2 orange, okay? Yes, there we go. We've got 4 left. Now, if I asked you, what is the probability of getting another orange marble? There we go. It will be 2 out of 4. Remember, Vicky, now there aren't five marbles in the bag anymore. There are only 4 marbles in the bag because we've removed an orange one. So if you look at the picture, you'll see now because we've taken out 1 orange marble, there are only 2 orange marbles left and 2 blue ones. So yes, then your probability would be 2 out of 4 blue or 2 out of 4 orange. This is where we're talking about a dependent probability. As soon as the outcome of one event affects the outcome of the next event. Okay? So let's look at, if I take out a blue ball, what would I have left in the bag? If I take out a blue marble, what will be left in the bag? There we go. Yes, Lionheart. As soon as one is taken out, the chances, it changes everything. Listen to the question carefully. If I take out a blue marble, this is now, if we still don't look at the picture on the screen. We're not using the same bag where we've already taken out an orange one. We're using the bag where we had 5. Okay? So if we use that bag and we take out, remember, we're still using this bag now. Okay, so if we use this bag, we take out 1 blue one, we will have 4, but how many orange and how many blue? What would be the probability of having blue? And what will be the probability of having an orange one? So there we've got 3 orange left, 1 blue. There we go, Megan, very nice. So yes, blue then, if we draw another marble, would be a 1 in 4 chance, and orange will be a 3 in 4 chance. So does everybody understand now what dependent probability is? Oops. Okay, yes. So as soon as one thing happened, the next thing we'll do will have a different outcome because the first thing have changed. How can we make this an independent probability? We can change this back to an independent probability if we draw one orange marble and we put it back in the bag and we draw again. Then the chances of us drawing orange will be the exact same. But because we've taken out one orange marble and we keep it, we don't put it back in the bag, you can see then we only have 4 marbles in the bag. Oh, that changed. Sorry, I just want to change back to my pen. Because now we've taken out the one orange marble, we've taken it out, and we only have 4 marbles left. Remember, the total outcome is? No, we are not putting it back. So that is why we then only have 4 marbles, and then inside the bag we'll have 2 blue ones and 2 orange ones. So there we will have an even chance of it either being blue or orange. But over here, if we took out a blue marble with the first pick, then we can see we have 3 orange ones left and 1 blue. Then because the total possible outcomes are now 4, 1 of which will be blue, and then 3 others will be orange. Okay, so an independent probability. Now we know that if a dependent probability changes when something happens in a previous event, an independent probability, the outcome of the first event, doesn't affect the outcome of the next event. For example, if we take a die, we roll it, we have a 1 in 6 chance, right? Now, if we take the die again and we roll it again, what will be the probability of getting a 5? It will still be the same. It will still be 1 in 6 because there's nothing been taken away. Even the flip of a coin, even if we flip it, the coin 5 times, nothing changes. The coin still has a head and a tail. The die still have 1, 2, 3, 4, 5, 6. So it doesn't matter how many times we roll it, nothing changes. Whereas with the bag, we take something away. So then I'm going to ask you guys 2 questions here, and then we'll go through 2 examples. Okay? State whether the following events are dependent or independent. Now, if we look at this example, it says a card is drawn from a deck of cards. We know that there are 52 decks, okay? 52 cards in a deck. Without replacing it, what is the probability of choosing 2 kings? Now, would this be a dependent or independent? Would this be a dependent or independent event? There we go, Vicky. Very nice. It would be dependent because if we take out 1 card, there aren't 52 cards anymore. It will only be 51 cards. Okay? It is a dependent thing. And then to answer Louis' question, yes, but that is when we study the outcome. Okay? So yes, we can say a certain coin will, the probability of landing on a head is different. But we're just going for, if we didn't study anything, there are 2 sides. We're just going to go for 50-50. Okay, so if I look at this one, 2 numbered dice, 1 red, 1 blue are rolled. What is the probability that the outcome of the red die is even and the outcome of the blue die is 5? Is that a dependent or independent event? Independent. Nice, Vicky. Yes, because the red die has 1, 2, 3, 4, 5, 6. It doesn't affect anything on the blue die. The blue die also have 1, 2, 3, 4, 5, 6. So it doesn't matter what we do. If we roll the blue die, it doesn't matter if what number came up with. It doesn't matter what number came up with the red die. The blue die is totally independent. So it will just either then also be 1, 2, 3, 4, 5, 6. Okay? Now we're going to quickly look at answering those two questions. Okay, so a card is drawn from a deck of cards, 52 cards, without replacing it. What is the probability of choosing 2 kings? Thank you, Musa. Guys, please focus. So we know it's a dependent probability. But what I want you guys to remember is when calculating probability of dependent events, we always assume that the first event happened as expected. Because if I ask you this question, what is the probability of choosing 2 kings? If I chose a 10 on my first pick, do I even carry on with the calculation? No, then I don't have to carry on with the calculation. Okay? Because then it's absolutely useless. So if we ask a question like this, we always assume that the first event happened as expected. So we assume that the first event, we got a king. So what do we know? That's what I told you guys yesterday. Always check first, what do we know? So first of all, we've got, how many cards do we have? We've got 52 cards, okay? And then in a deck of cards, how many kings do we have? How many kings do we have? There we go, Lionel. We have 4 kings in a deck of cards, okay? 4 kings. So what would the probability be of us? This is what we know. We've got 52 cards and we've got 4 kings, okay? So what would the probability be of drawing a king on your first try? There we go, Lionel. Yes, it would be 4 over 52. 4 kings in a deck of 52 cards. Okay? Is this a simplified form? Is this a simplified form of the decimal? No, it's not. So who can tell me what would be the simplified form of 52 of 4 over 52? There we go. 1 over 13. Now, because we assume that the first event, we drew a king. Now we move on to the second. Okay, so what would the probability be of us drawing another king? Now remember, we do not, it says over here, if we look in the question, without replacing it. Without replacing it. Okay, so how many cards do we have left in our deck? How many cards do we have left? We've taken out 1 king now, so how many cards do we have left? We didn't take out all the kings, we only took out 1 card. We drew 1 card, there we go. So we've got 52 cards left, 51 cards left. How many kings are left in the pack? Because now we've taken, there we go, 3, because we've taken out 1 king. So what would the probability be of getting another king? Lewis, remember, if we kick you off the group, then you won't be able to come back. So please pay attention and only stick to the questions asked, okay? Thank you, Lionheart. Yes, the probability of drawing another king will be 3/51. Now, can anybody give me a simplified form of 3/51? Simplified form of 3/51. What would that be? There we go. Thank you, Vicky. Sharon, very nice. It will be 1/17. Okay. Now remember, this is just the probability of each event happening. Now we have to answer, what is the probability of us choosing a king and then another king? And what we do with that is we take our two answers, 1/13 times 1/17. Who can quickly do the math on that one for me? What is the probability of getting two kings out of a deck of cards? What is 1/13 multiplied by 1/17? Ooh, nice, Vicky. Fast. Yes. There we go. The probability of us drawing two kings is 1 in 221 tries. Okay? Yes, that is very unlikely. Okay, so yeah, this we will move closer to. There we go. Fast as lightning. Very nice. Yes, so it will be a 1 in 221 chance of drawing two kings. I just want to make this statement again about what you need to remember. Always remember, when calculating probability of dependent events, we always assume that the first event happened as expected. Okay, otherwise we don't even have to carry on. The second question we had, it was two numbered dice, one red, one blue, are rolled. What is the probability that the outcome of the red die is even and the outcome of the blue die is 5? Okay, so the first thing we do is remember the two die roll independently of each other. They don't affect each other. So what would be the probability of the red die landing on an even number? Who can quickly tell me? What is the probability of the red die landing on an even number? There we go, 3 and 6. Why? Because the even numbers are 2, 4, and 6. Okay. So 3 and 6. And if we simplify that, we have 1 and 3. There. 1 in 3 or 1 and 2? 1 and 2, remember? Okay, so then the blue die. The blue die landing on 5. What is the probability of the blue die landing on 5? There we go, 1 in 6. Now the question didn't stop there. The question said, what is the probability that the outcome of the red die is an even number and the outcome of the blue die is a 5? Okay, so we need both answers to be, or we need both events to, we need to calculate both events together. So for the probability for the red to be even and the blue to be 5, we have to times 1/2 times 1/6, and our answer would be 1/12. There we go. Very nice. I just want to make sure you guys need to remember that these two things happened independently of each other. But if we want to get the total probability of the two events occurring at the same time, we multiply them together. And then like you guys mentioned, now we have 1/12. Okay, so I'm quickly going to give you guys some homework. I want you to, there we go. I want you guys to screenshot this for me quickly or take a picture. It's going to be very similar to what we've just done. A bag contains 3 red balls, 2 green balls, and 6 blue balls. Okay? If we choose a ball, then another ball, without putting the first one back. Remember, read the questions carefully. Without putting the first one back in the bag, what is the probability that the first ball will be red and the second ball will be blue? Okay, go and do it the exact same way we did the previous questions. Write out everything. What do we know? That's the most important thing. What do we know? If you want to take your pencil or your make circles, you know what? We've got 3 red balls. We've got 2 green balls. We've got 6 blue balls. Okay. What is important? If we choose a ball and then another ball without putting the first one back, those are important things in our question. Okay. Thank you, guys. Those are important things in our question. And then we just go and draw yourself little pictures if you have to. Okay, draw yourself little pictures if you need to, like we did in the question before. I'm going to go back all the way quickly to this one. Draw yourself little pictures like that if you have to, so that you can work out exactly what you need to do. Okay, but thank you, guys. I just want to see quickly, go through. That is your homework. I just want to go back to the homework quickly. Make sure that everybody has made a screenshot of that. Okay. Tomorrow, we're just going to work through some questions. Okay. These are our helpful links. Remember, you guys can get some extra questions at siavula.com or theeducation.gov.za. But thank you very much for joining us again today. I loved having you guys again. And thank you so much for you guys being so wonderful and coming back, really trying hard. I really appreciate it. And you'll see, you know what, effort pays off. Thank you very much, guys. I hope you have a wonderful day. See you tomorrow. Bye-bye.